Okay, so we come to section 5.3, finding solution graphically. Okay, so let me take. Okay, so now we're gonna revisit example 5.6. We're talking about the company produce a basics and premium version, right, of its product. So let's take a look at what we did before first. Not this one, right? So we tried to, we didn't have the system inequities set up as 20x plus 30y less than or equal to 39 hundredths, and then 15x plus 30y less than or equal to 33 hundredths. And we did draw like a graph, the area we're gonna be like overlap shading area, purple one over there. We consider this one, and this one it show us all the possible combination of the basic premium. The thing in here is we try to think about which one is the best for them to like maximum the profit or maybe minimum the cost. All right. So let's we figure out what is that. Okay. Now I just gonna in here I did redraw the overlap shading area. Let's say yes. Okay. Overlap shading area. Now we name is as feasible region. Which is all possible combinations of basics and premium. Okay, and keep my that now we have a new name for this area that we call feasible region. And last we go ahead and put out the linear inequity system, 20x plus 30y less than or equal to 39 hundredths. And the second one gonna be 15x plus 30y less than, I put the equals later, 33 hundredths. Okay, so equal sign. Okay, and this need to have like a curved little cat, and we and the solution of this system is the shaded area over there. Okay, so in the shaded area, with combination gives a maximum maximum profit. Right. So let me make this red here. Right. In the shaded area, weak combinations give a maximum profit. So all of this in here is the the solution of this system, but we want to know one of them. We want to know is that one of them that maximum the profit, right? So what is the profit function? We need to know that, right? So so let's we state the profit function. Is P, and how to have the profit. So read the question here carefully, and we can see the sentence say, they sell basic product for a profit of $30. Maybe I use other color better. Basic will be a green. Right? Basic for profit of $30, and they sell the premium products for $40. So that means how many so that means each basics gonna be $30 times with how many item of basics? X, right? Ending with $40 for each premium. How many premium do we have? Y, right? So profit will be 30x plus 40y. Okay. And now we need to have some idea to maximize this function. Okay. So there's three different values of profit. I will say here. There are three different values of profit, P. But we need to be in the visible region. Okay. So take a look at this now here. We have, and you see down here, if I draw, let's draw the lines that the line for 30x plus 4y equal to something over here. Let's say if I have you have this line, I will have profit at $6,500. However, this line is not in the feasible region. So this is a little bit confused. Like you maybe you're gonna say like, why we have three different values here? I just assume, okay, maybe assume we have three different values. I just assume it, right? I just want to have three different values of profit, and I got this line, this three line, right? The thing in here is I want to show you that the line must be inside of the feasible regions. So that line will be a valid for the profit of the of this company. Okay. So you know what? Let me just show you how I have it in in decimals. Okay, so let's go ahead and get in the decimals and put out the inequities first. Maybe we need to adjust x will be from 0, and I will go up to 250, maybe more. That should be okay. And y values will be from 0 and up to say 160. Yeah. So this will be the 2 line for the inequities and all the shaded area. But keep in mind that we just consider about the overlap shaded area, which is the purple one over here, which is the feasible area. Okay, feasible area here. Okay, so I will maybe okay, I will have P equal to 30x plus 40y. Okay. Okay, now. Oh, why it's not interesting. Let's see. I'm gonna put equal to P instead of P equal to. I put like this better, okay? Because they seem like they don't really like me to put P in front of it. Okay, so after that, I will have to add the value for P. This is like I assume, okay? I assume that P run, I'm gonna say run from 0 and up to, I don't know, 6,500, okay? 6,500. This is, and I wanna play it. And you see that is gonna be the multiple parallelized. Like, for example, if I have P equal to 2,000, say 2,000 here, right? You will have profit is 2,000, and the x value and y values must inside of the. I mean, if we have the line inside of the purple area here, which means we will have the x value and y values in there certified for the profit to be 2,000. Okay, but this is not the maximum profit we are looking for, because we can make it higher. Let's say 4,000. Oh, it's still inside of the purple area here, and absolutely find something like this. Okay, what about 6,500? Oh, it's outside a purple area already. Look like we want to have this amount, but we can't do that. Does that make sense to you guys? Okay. So we want to play around with that. And you see, like, you know, try to move around with the value of P, and until you will you will have the maximum, and you stop there, right? You see right now, you have maximum value, but you also need it to be stopped at the purple area, right? It's still inside of the, not inside, but it's still touch the purple area. Okay, so for example, if I move this and over here, look like it's the rest is outside, but there's the point here, it touch my purple area, right? So that's look like I can I can have the profit to be 5,840 at over here, right? At maybe x equal to I don't know, maybe right now I have x equal to 192 and y is 2. Okay, but I can even make it higher by 195. So move a little bit more. Okay, I think this is perfect. All right, look like is that touch? It's not really touch. It's kind of like a outside already. But this is what I guess if I have 50 here, right? Yeah, it's gonna be exactly as x equal to 195 and y equals 0. I will have the profit line touch the feasible area or feasible regions, which means I will have the maximum profit as 5,850 and there is a x and y value certified for that maximum profit. And there's no way you can have higher than that, since after that you can right away get to the the outside of the feasible value. See that, right? So or if you move down a little bit, it's going to be less than, right? So so right now I come up with the idea that the maximum profit will need to be first will need to be in the feasible region, and it's supposed to be like touch the feasible regions, and it's also gonna be like in the corner, could be in this, like in the touch of the intersection, like a profit line will be like at exactly at the corner of the feasible region, right? So it's at this case, it was exactly at this corner here, 195.0. I mean, if I want to get rid of the area red and blue here, say, okay, so let me how to do that. Let's see. Yeah, I think that's okay. Okay, so let's come back with what we have here. I will post the, I will put out the link for this most. Okay, actually put this one here. All right, for this one, right? So we can see that we want to move want to move the orange line up and touch the shaded area or visible region, right? Touch. Oh, touch shaded area. Okay, so what about so then I also did show you guys there is only one case make the highest profit P according to Desmos and according to Desmos, which is at the corners point 195, 0. We will make at this point our max profit, our profit will be P equal to 30x. X now is 195 plus with 40y, right? 40 times 0. So we have P will be equal to 5,850. You can check that with your calculators. But I'm pretty sure you will have that, okay? So that is it. Okay, so this is max profit. Okay, so this is just graphically, okay, and we can say max profit is about 5850, right? With producing 195 basics and zeros premium products. Okay. So according to the problem above, we can make a conclusion that the feasible regions is the areas in the graph that satisfies all the constraints simultaneously, right? Okay, so fundamental theorems of the linear programming, according to the problem above, we can have fundamental theorem as of linear programming as 3 things here. First, if a solution exists to a bounded linear programming problem, then it occurs at one corner point. Like I say to you, right? It must occur at one corner of the point, at one corner points of the feasible region, if you have it. Okay, and if maybe I use this. If a feasible region is unbounded, Okay, so unbounded mean you don't have any something that's bounded it and it just run everywhere, right? Then the maximum value of the adjective do not exist. So do not exist in this case. The maximum value, as I say, do not exist. I would say maximum and minimum values, right? Because sometimes we may need to do the cost, minimum the cost, right? What about if a feasible reason is unbounded and the objective value has only positive and the objective value has only positive coefficients? Okay. Then minimum value exists. I actually decide to get back my word here. Let me mean here. Yeah, it should be okay. It's just so mean will be down here, right? We're just gonna not gonna have the maximum since the feasible. It's just go everywhere. All right. Okay, so now we move to example 5.7. Actually, you know what? Before moving to that, I would say we most likely working on this case in this class. All right. And so we most likely gonna try to find the maximum profit or minimum cost in this class, something like that. All right. Okay, and we most likely gonna have the solution actually. All right. So let's move to example 5.7. Okay. So let's read this one. A health food business would like to create a high potassium blend of dry fruit bars. It decided to use dried apricots, which have 407 milligrams of potassium per serving, and dry dates, we have 271 milligrams of potassium per serving. Okay. The company can purchase its fruit in bulk for a reasonable price. So dry apricot costs $9.99 per pound, about 3 servings. Okay, and dry date costs 7.99 per pound, about 4 servings. So I think this is important information since it's talk about money things. So dry cost this, all right, and about 3 servings, and we have dry date cost this, and this about 4 servings, right? The company would like to apply the box of bar to have at least the recommended daily potassium intake of about 4,700 milligrams. Okay, so this is important. We need use this color, 4,700 milligrams, and contain at least 1 servings. So contain at least 1 serving of X fruit. Okay. Uh, so that means what? That means I also need to highlight 407 milligram per serving for dry apricot and 271 potassium for dry dates. Okay. So what is the question? I'll use the red one here. In order to minimize the cost, right? We want to minimize the cost. How many servings of each dry fruit, right? So we want to, according to this sentence here, we need to name them, right? So that's the reason why I decided to name, right? X is number of serving of dry apricot, and Y is the number of serving of dry days, right? So let's make the cost function first. I'm gonna say here, apricot cost. Apricot cost how much? $7. Did that? No, $9.99. We want to make in servings, right? So because we want, this is the 99 for 3 servings, right? So so when I say per servings, 9.99 divided by 3, which equal to 3.33 for each serving. Okay, so X servings. So that means what? For the cost of X serving is going to be 3.33 times X, right? 33 times X. What about dry date? Date cost per serving. We know that it's going to be 7.99 for 4 serving, right? So I'm going to say 7.99 divided by 4. Which going to be about how much? Check this. This number 171.9975. So I need to round 2 decimal place. So we are gonna do $2 for each servings. Okay, let's just round it out. So I'm gonna do $2 for each servings. That means for the cost of how many servings per day do I have? Y, right? Servings will be equal to 2Y. Okay. And now I'm gonna change this color to be blue. Okay, so because of that, I will have total cost width is C, gonna be equal to 3.33x plus 2y. Okay, and we want to minimize the cost. All right. So with this here. So is there any restriction for that or requirement for that or for X and Y things or any constraint? We call that, right? They say over here, it's a at least one serving X fruit, right? At least one servings of X fruit. So that means what? X must be greater than or equal to 1. I put equal later. And Y must be greater than or equal to 1. Okay. So product must have at least what else? Let's say product must have at least 4,700 milligram. Put that here. Okay. Potassium. So then, what I'm gonna say here? What inequities as I'm gonna have in here? So and you know that we have 8 dry apricots made 407 milligram, right? So 407 x. Adding with X serving will have 200 X serving of dry dates will have 271. Why? I'm going to use this. Less than or equal to 4,700. Okay. So we have some constraint as yeah, 2 constraints right now, right? Actually 3 constraints right now. All right. Okay. And anything else? That's it, right? Okay. So we want to minimize the cost. C equal to 3.33x plus 2y. Or maybe I'm gonna put out put that here. Minimize. I'm gonna put that here as a conclusions. So I'm gonna minimize this guy with constraints. Constraints gonna be copy this one. Okay, and x must be greater than or equal to 1, y must be greater than or equal to 1. Okay, so this is what I have. Okay. So now we're gonna draw the graph. Okay, we draw the graph of it. Okay, so in the right hand side here, I have 3 lines. One is x equal to 1, and one is y equal to 1, and the line 407x plus 271y equal to 4,700. Okay, but look like we are not, the feasible region is not bounded by these 3 lines, right? They are all solid lines, and this includes the equal. But as you see right now, the feasible region look like it's not it's about it. Okay. How do I get this one, right? I mean, you can go by the way, by the hand way that I show you in the last section, but I allow you to use decimals that you can just put out here for say x greater than or equal to 1, y greater than or equal to 1, and then we have what else? 407 x plus 271 y greater than or equal to 4,700. Okay, maybe we need to adjust a little bit. Say x must start from 0 up to where? I'm gonna say 25, and y also need to adjust up to, I don't know, maybe 20, 25 or so. Okay. All right, so as you see now, the overlap shaded one gonna be just this one. Maybe I need to see if someone is better. Let's use this one. Yeah, like this. Yeah, I think that's good. Okay. So the feasible area will be the one really overlap, which is just, I'm gonna use just to here, and here. And you can I can say this area over here, right? And then see that the left hand side was about 3 lines outside, like in the right hand side, it's not bad. It can keep going further. That means there's no maximum in here at all. I mean, you cannot find maximum because it just keep going up. But for the minimum, yes, you may have it by by somewhere in the corner of the feasible regions, right? So right now we may need to find what is this point. Okay, let me clean this up. What this point, according to decimals, I can have 115.8 something and 10.8882 and 1 here. Oh, is 10.9, come on, 1, right? So so I would say I'm gonna label this section, this intersection 1.15, 1.15, 1 comma, sorry, what was it? 1 comma 15.8, right? Net using the red one here. Okay, and this intersection point will be 10.9 comma 1. Let's just approximate it. So these two intersections, I got it from using decimals, right? So I have to say using decimals, using decimals, I can get two intersection point, two intersection point, or two corner point, two corner points of the feasible version. That's below. So maybe I'm gonna just say blue one. Okay, so we can say this region is unbounded. So then, and we have only positive coefficient of the objective function, with the cost function there, right? We just have positive one, right? 3.23 and 2. Then we must have minimum access. Yeah. Use this as the green one. Okay. Okay, so we did have 2 points. According to the decimals, we can put those 2 points into here because we want to know which one will give us the minimum of the cost. So just put out those 2 points over here. You know what? Here's 2 points here, right? Okay. So for the point 1, 15.8, we will have the cost as, oh, you know what? Maybe I need to separate it better. Okay, yes. So let's separate it. Okay. So for the 1.15.8, I got the cost will be equal to, let's copy this one, right? Equal to this guy, but X now changed to be 1 and Y now changed to be 15.8, right? So according to this, you will have 34.93 as the cost. All right, $34.93. Okay. And according to this point, we have cost will be 10.9 for X and 1 for Y. We're gonna give us 38.90, no, for the 30 cents. So which one is smaller? And you see that this guy is smaller, right? Minimize is this guy. Okay. So, like after comparing the 2 corner point, so maybe I can put that here. Let's comparing 2 corner points to get the minimum cost. So according to this comparings, we have the minimum cost going to be 34.93 cents. By using how many serving of apricot? So X is 1, right? And how many serving of dates? 15.8. Okay. So this is gonna be the answer for this problem. Okay. All right, and let's do one more. So like according to the example above, what I did was first set up the minimize set up the optimize equation and the constraint, and then find the corner point by decimals, right? Maybe I'm gonna say some step here. Step 1, set up optimization equation with constraint. Step 2 is using decimals to get the corner points of the feasible regions. Okay, and step 3 is comparing the corner point to get the minimum cost. So that is a way to do optimization for this section, right? Okay, let's using that 3 steps to handle the next examples. I think this, okay. So examples 5.8, a factory manufacturers chair and tables are requiring the use of 3 operations, cuttings, assembly, and finishings. So cuttings, assembly, and finishings. Okay. So the first operation can use at most 40 hours, and the second one, at most 42 hours. Maybe I have to highlight those. I'm actually gonna say at most 40 hours. All right. The second will be at most 42 hours, and the third will be at most 24 hours. And the requirements are shown below here. Okay, so we have 2 items, chair and tables. Okay, so cuttings for chair need 1 hour, table 2 hours, something like that, right? Assembly 2 hours for chair and 1 hour for table. Finishing is 1 hour for chair and 1 hour for tables, something like that. Okay, so now we have profit is $20 per chair and $30 per tables. So what we want to find in here is how many units for each, right? To maximize the profit. So we need to name them. Okay, maybe let's practice with some new name instead of X and Y. Borrowed things. That name. The number of chair will be C, and the number of table will be T. All right, so chair is C, and tables is T. All right. So how can I have the profit function? So P will be equal to because each chair costs $20, right? So 20 times C plus 30 times T, right? Because each table costs sell each table $30, right? So we want to maximize profit. Okay. Cuttings. Okay, so let have constraint. Like let's set up the constraint. Constraints. For cutting we need 1 hour for chair and 2 hours for tables. So will be 1C plus 2T, right? And it say like for cutting at most 40 hours, right? Is that correct? Let me see. At most 40 hours. Oh yeah, that's correct. 40 hours. Okay, so maybe I'm gonna use other color in here. Say cutting was using the pink one. Right. Then the second one will be assembly, right? At most 42 hours. The last one will be finishing, 24 hours. So we have this is less than 40. See, we say assembly can be used at most 40 hours. Right. So say that. Maybe I'm gonna make less like that. All right. What else do I have? Or maybe I'm gonna put that here. Oh, sorry. Cutting. Next. So we need to make it less than or equal to 40 only, right? At most. The next one say, let's use the, no, actually, okay, let's use the assembly. Assembly can be used at most 42 hours. All right. So that means what? According to assembly here, I have two chair, ending with 2 hours for each chair, right? And 1 hour for one table, or for each table, right? And then less than 42 hours. That's my equal. See this, say at most. Finishings can be used at most 25 hours. So we will say, according to finishing here, 1 hour for each chair, right? 1 chair, adding 1 tables, less than or equal to 25 hours. So this includes equal. Any other restrictions? I would say no negative. No negative items. Right? So we mean, I would say, and the number of chair, number of items must be greater than or equal to 0. Would be not negative, right? So what I according to that, what I can say, I can have C greater than or equal to 0 and T greater than or equal to 0. All right, so yeah, so that's it. Okay, so combine all that. Combine all that. All right. I will set up the optimization equation with constraint over here is gonna be I'm gonna rise over here. I want to maximize, not minimize, right? Maximize the profit will equal to and with the constraint will be this y what else? 2c plus 1t less than or equal to 42. I put that equal later, right? 1c plus 1t less than or equal to 25. And lastly, c must greater than or equal to 0. This guy also t must greater than or equal to 0. Okay. Makes the equal things. All right. So we have maximize constraint over here. Now we're gonna need to use step 2, which is using Desmos, right? Using Desmos to draw it, to grab it, right? To get corner point of the feasible regions. So feasible region gonna look like this, okay? After you grab it by Desmos, and you need to know what is the point for each of the intersection here, right? Each of the corner there, right? We need this. I think that's gonna be 0.20, and this will be something like 21, 0, something like that. Okay, but let's put everything in there, right? Okay, so let's get in decimals. Actually, by using decimal, you must using instead of C and T, you must using X and Y, right? So must change a little bit for that. So we'll have P's equal to 20X plus 30Y. Maybe I put down, no, maybe, no, we don't need this one, sorry. We just need to put out the constraint only. So X plus 2Y less than or equal to 40, right? That's the first one. X plus Y less than or equal to 25. What's that? 42. With 2X plus Y. 42. The next one gonna be X plus Y less than or equal to 25. And next one gonna be X equal greater than or equal to 0. X greater than or equal to Y greater than or equal to 0. Okay. Need adjust the Y and the X. I would say will be up to X can be up to I don't know, maybe 20, 30. We don't really need it up to there, but maybe 25, that's good enough. Because you see that the overlap regions, I mean, the feasible region is just this guy over here, right? So I don't think that we have to go further than that. That should be okay. Maybe I need to use different color, maybe. Can I? They don't have so many different colors. Okay, so that's okay. That's fine. So we have, let's check that. Okay, we have this guy. We need this corner here at 10, 15. This corner over here, this part over here. What is that? They also tell me is this gonna be, oh no, we don't need this one. This one is not in a feasible region. We need this one, right? 17.8. Okay. I really want to get to this point, so maybe I move a little bit far. Okay. So this now showing me 0.20. Good. I need this point, 21.0. All right. So according to decimals, I will have the first corner over here is 0, 20. Make it red. Second color here will be 10, 15. This one will be, what is that? I forgot. 17, 8, right? Check to make sure. Yeah. 17, 8. And the last one will be 21, 0. I put here. Okay. So we have 4 corners totally, right? We have 4 corner points. 4 corner points. So first one will be 0, 20. Second one is 10, 15. Third one is 17, 8. I don't know why I put that point. Next one is 21, 0. We missed something? I mean, it's 10, 0, 0. Oh, this one. I missed this corner. All right. So don't forget this corner, right? Okay. So put out this corner there. But I think that will not be the one we are looking for because 0, 0 will not make any profit. Thus the profit equation will be 20C plus 30T. I mean, I would recommend that this change to be X and Y values, right? So we don't have to worry about, put it in the decimals. I mean, I want to change that. I want to change that. Change it now. Change everything to be X and Y because I want to make it to be consistent. So this is X, this is Y, X, Y, X, Y, X, Y, X, Y. Look good to me. I also need to change this guy. Let's change it to be X. And this to be Y. Okay. This is X. This is Y. This is X. This is Y. This is X. Y. Okay. There is anything? No, right? Nice. So I'm going to change it to be X and Y. All right, nice. So now I will just plug in 0, 20, so going to be 20 times 0 plus 20 times 30 times 20, right? So that gives us 600. What about this guy? This guy gives this guy will give us E equal to 20 times 10 plus 30 times 15. Try that on the calculators, you will get 650. Oh, okay, higher. All right. So the next one, you have 20 times 17 plus 30 times 8. What do you have? 580. Okay. Next one. P will be equal to 20 times 21 plus 30 times 0, which give us 580. Alrighty. Lastly, we have profit will be equal to 0, 20 times 0 plus 30 times 0 equals 0. So you can see which one is maximum now, right? So the maximum one I have right now is this guy. It is max. Okay. So according to that, I can say that the maximum profit is 650 by producing 10 chairs and 15 tables. Okay. And I change it to be green. So that's going to be it for, actually, I should state step 3 here. Right? When it is comparing points to get max profit. So that's going to be the last step. And we have exercise 5 here. I would like to let you guys to practice on that. And I will give you guys the answer key in here, going to be 0, 2000, 1500s, and 1000, 2500s, 0. Try to get the profit function, and the answer key will be 6,750 by producing how many t-shirts? 1,500 t-shirts and 1,000 long sleeves. So I wanna I also wanna talk about this in class if I have chance. Okay. Then we're done this session here, and we're gonna stop here. See you guys. Actually, gonna hope everyone enjoys the class, right? All right, bye.